should have 4.
No?
4 every day.
No, I got it.
Oh, yeah. It's just a mini quiz, and it's really just to try to get you to learn.
Yeah, I did all that stuff in the high school today, so. It's all right.
What? We don't have to. We do? Oh, okay. I think. Like, just the matching though, the inverse. Oh, yeah.
So you're
Sign was like a rainbow.
Yeah. No, signs out. Yes, we do. What?
Oh no, buddy.
Well, you have a quiz.
Did I draw it wrong? I'm gonna look over. Signs like
No, but you have a quiz.
yeah. Oh. Sine, cosine, and tangent. Cosecant, sorry, I'm at cosecant. Yeah, okay.
No, you're cosecant stop.
Cosecant
Cosecant's this.
Yeah.
Cosine is this.
Yeah.
Cosine,
Sine, cosine. Sine is like this. Cosine and
I got it blocked.
actually. And then.
You're watching that.
Does that? And it's like.
What were they called?
It gives you, you can look at it.
It's like football players.
You just have to know secret. Secret.
Cosecant. Or sorry, sine, cosecant, cosine, secant. And like secant first. Trapped or something? Yeah. Got 2 hit traps. Yeah.
Well, yesterday.
Oh, it's worse than the second day.
I know, bro. No, I was doing them, and I put it down, and it was still like super tight. I was like, oh my gosh, what is this? Alright.
Diego.
Sine.
Cosine.
No. I got it all in one box. I feel like I can get it. I feel like it'd be fun. Get food. You have to buy it. We're stopping somewhere to get food.
Are we actually?
No, you have to bring your own
Alright.
To start off today, we've got the matching mini quiz. So you don't need to put your phone and such up, but I do need you to clear your desktop. So, real quick. What's that last name? Okay, so it will be 6 homework points. And it is matching, so at the top it's got the answer choices in both the unit circle format and the index format. I mean, at the end of the semester, I wasn't thinking it would impact your overall grade, but just kind of thing. Okay, please put your name on it, and you should probably number it as 39. Again, it's just a quick one, no tricks, no surprises. Everything has one answer, 6 choices, 6 answers. So even if you know most of them, the last ones you might be able to get with process of elimination. And truthfully, you really need to know these much better than just matching. But I felt like this was a pretty good compromise for the first day. That way you're at least pushing yourself in the right direction. Of course, please double check your work before you turn it in. And when you come turn it in, please do so quietly. If y'all can't do it quiet, just wait. While we wait and give everybody a couple more minutes here, I also would like to grade these and get them back to you, because if you think that you got some of these right, but you got them mixed up, that could mess you up on some stuff that we're doing today. So, give me a few minutes to grade these and pass them back to you. But while you wait, one of your handouts you picked up this on the way in, number 40, is on graphing inverse trig functions. And at the very least, you could do the sine, cosine, and tangent graphs while you wait. You will also need a calculator today, so if you need to borrow one of mine, you could come and get that while you wait for the last quizzes. let me pass the rest of these back. Again, 6 homework points is not a lot, but hopefully it helps you see that how well you have those memorized. I know we only have been in this section one day. Today would be day 2. But most of our work will depend on you knowing these. So if you do not have them memorized for today, you need to do that as soon as possible. All right, and we're going to look at one new thing, but kind of 2, I guess. We're going to look at graphing inverse sine, inverse cosine, or inverse tangent next on handout number 40. And I actually did that with you already in the notes, but I will say it one more time for that handout. So when we get to your quiz, which is a week away, again, there's no school on Friday, so that puts the next time I see you next Monday, and our quiz is not next Monday, it will be next Wednesday, so we've got some more time to get this figured out. But we will not ask you to graph inverse secant, inverse cosecant, or inverse cotangent, but we may ask you to graph inverse sine, inverse cosine, or inverse tangent. So we'll make sure that you understand the process from that. Then we'll talk about the other handout, how to use your calculator with inverse trig functions. Then the homework that you guys had last time, the parts of worksheet 2 that I asked you to do, I will try to help out and go over some of those that you struggled with. And then at the end of class, I ask that you start on this book assignment, and you won't get very far on it, but you don't need to have it finished by Monday anyway. So, but the more of it you get done in class, the better. Okay, so I'm not going to talk about the graphs of sine, cosine, and tangent very much because we just did that in the last unit, so you know what those look like. But to graph inverse sine, inverse cosine, and inverse tangent, one thing that makes this helpful is if you know the domain and the range of these. It's not that you have to write this to be able to get the graph correct, but you'll see why I like this approach. The range is one of the questions that was just on your quiz. This one was negative pi over 2 to positive pi over 2. And if you think about what range means, this is describing the y values of the graph. So my y values of inverse sine should not exist below negative pi over 2 or above positive pi over 2. It's going to exist just between these y values. And the domain of inverse sine came from the range of regular sine. And the range of regular sine was negative 1 to 1. And the reason that can be helpful for your graph is because it tells you inverse sine does not exist left of negative 1 and right of positive 1. But to actually get some points of this graph, you have to steal some points from your sine graph. Sine has 0, 0. Switch x and y, because that's all input means. Input functions mean you're swapping input with output. So in this case, it's x and y. You swap x and y, replot it, you still get 0, 0. Take another point, like pi over 2, 1. Switch x and y, and that gives you 1 pi over 2. You can plot it. Maybe still this point, negative pi over 2, negative 1. Which would become negative 1, negative pi over 2. And of course, the more points you switch x and y and replot, the more confident you're going to be. But this is what inverse sine is going to look like. Try not to make this look like a straight line. This is not a straight line. This really shouldn't be a straight line either. Try to do a little bit of curvature to it. But that is the whole graph of inverse sine. This isn't just like one cycle that we copy and paste a bunch of times. This is the whole thing. But again, so you can hopefully see how domain and range kind of helps you box in to even know where you should care about. So doing the same thing with cosine. At the end, I'm going to steal a few points from cosine, switch x and y, and replot them for inverse cosine. So it, of course, helps to know what cosine looks like. But I'm going to start off with kind of boxing this guy in too, even thinking about where he exists. So the domain of inverse cosine is the same as the range as regular cosine, which is -1 to 1. This helps me know my graph should not exist here or here. That's why I'm thinking about that. The range, this is one of the questions that was just on your quiz. The range of inverse cosine is 0 to pi. So my graph should not exist below 0 or above pi. This little bitty spot is the only place where inverse cosine exists. So take a point like 0, 1, switch x and y and replot it, becomes 1, 0. Take another point like pi over 2, 0, switch x and y, you get 0 pi over 2. Take another point like pi -1, switch x and y, you get -1 pi. And then same thing. This is not really a straight line. It kind of looks straight, but we know that there's some curvature to it. So do your best to show a little bit of curvature. That is what inverse cosine looks like. And once again, this isn't one cycle, that's the entire thing. You have to remember that we restrict the domain of cosine, which is why inverse cosine doesn't have as much to it. We have to ignore most of the cosine graph. Okay, and then last one, and then make sure that you guys don't want to ask any clarifying questions, but if I'm trying to graph inverse tangent, even though it doesn't ask me to do it, mentally I'm thinking about his domain and range. We will ask you these questions on your next quiz anyway, so you need to know them for that. The domain of inverse tangent is the same as the range of regular tangent. So I know my graph should go forever left and forever right. That's why I want to think of that. And then range is the part you just took a quiz over. The range of inverse tangent is -pi over 2 to +pi over 2 with parentheses. So my graph should not go below -pi over 2, and it shouldn't be bigger than pi over 2. Inverse tangent should only exist in this little bitty area. But to get a couple points so that you're not trying to memorize a different graph, know what tangent looks like. From last unit, and then still some points. This guy has the point 0, 0. Switch x and y, it's still 0, 0. This guy has a point at pi over 4, 1. So his inverse would have a point at 1 pi over 4. I would probably take this point, which is -pi over 4, -1, which would become -1, -pi over 4. You can copy over any points you want to, but if you know the x values that are supposed to be part of your graph, and you know the y values that your graph is limited to, that should keep you from having to copy over too many points. That is what inverse tangent looks like. Forever left, forever right, like the domain that I know it to be. Range approaches -pi over 2 but doesn't reach it. Approaches +pi over 2 but doesn't reach it. I got a few specific points by taking a few specific points on tangent and swapping the input and the output. Okay. You guys have anything you want to clear up about how to graph inverse sine, inverse cosine, or inverse tangent? Again, I know we did those in your notes last time, but you saw a lot of stuff last time, so. Okay, then next up, let's look at honestly, this is the only completely new thing today, but there's just so much in this unit that we'll still stay busy the whole time. So I need you to know how to do inverse trig functions in your calculator. Some of these are going to work out really nice and neat. Some of them take one extra piece of knowledge to do, and then there's one that takes some pretty deep thought and to be able to do. Now, when we talk about inverse trig functions, mathematically, these really only exist in radians. So, as we practice these, our calculator must be in radian mode. And you've already used your calculator with some inverse trig functions before when you were finding some angles in SOHCAHTOA. And so if you want inverse sine, you hit second sine. You want inverse cosine, do second cosine. You want inverse tangent, do second tangent. Your calculator has those functions built into it, and the fact that your calculator puts those as a button on your calculator means that they have programmed those in. They know how those work. So when you ask an inverse sine question, it knows the range of inverse sine and it makes sure it gives an answer within its range. When you ask an inverse cosine question, it knows the range of inverse cosine and it gives you an answer within its range. But these are the ones that just work out nice and neat. So if you want to know inverse sine of 0.5, make sure you're in radian mode and type in inverse sine of 0.5. This one just works. Nothing special needed. We're going to round to 3 decimal places, 0.524. Okay, if you want to know the inverse cosine of 0.867, just type it in, hit enter, and you can trust that answer as long as your calculator is in radian mode. It's about 0.522. And the other one that just works is inverse tangent. And it's about negative 0.254. Okay, so since these have been pre-programmed in our calculator, these are the ones that just work and we don't have to do anything special. But if I go and type in inverse cosine of 1.5 into my calculator, before I hit enter, well, you know it's not going to work because I said it on the worksheet. Any idea why my calculator is going to fuss about this? Okay, let's hit enter. What's its error message? Try to give us a hint. Domain. What is the domain of inverse cosine? Okay, and so in mathematics, why we care about that idea of domain so much is it's a quick way to describe what numbers make sense to plug in. The domain of inverse cosine is -1 to 1. So if you plug in a number bigger than 1 or bigger than -1, it doesn't make sense. If you want to think of it as like cosine is adjacent over hypotenuse, hypotenuse has to be the biggest side, so cosine can never be bigger than 1. So you're asking your calculator, give me an angle where cosine's bigger than 1. And he understands that that doesn't make sense, and that's why he's giving you an error message. He's trying to give you a hint in the error message, but he still does the question just fine. It's just that that's not possible. Okay, taking one step forward, now we'll talk about inverse secant and inverse cosecant. Your calculator does not have these buttons. It doesn't mean that your calculator can't work them though. So, since inverse cosecant, or cosecant's the reciprocal of sine, and secant's the reciprocal of cosine, I want you to write this on your paper, but this part's not correct. The most common guess on how to do this is to do 1 over inverse sine of that. So put that on your paper, but put an X through it. The reason why this doesn't work like this is because in inverse functions, inverse function returns an angle. All of this represents an angle. And if you do 1 over an angle, you're giving the reciprocal angle. And I can't think of a single time in mathematics where I ever need a reciprocal angle. What we want is the reciprocal ratio. So you have to remember how this is formatted. In an inverse function, the thing you're plugging in is the ratio. So you have to do the reciprocal ratio, which is the inside part. And then same thing with inverse secant. The closest we can do is inverse cosine, but we need to make sure we do the reciprocal ratio, not the reciprocal angle. Instead of inverse cosecant, we could do inverse sine, but reciprocal ratio. Instead of inverse secant, inverse cosine, but reciprocal ratio. I'll just use mine. Okay, so as long as you are careful about that part, your calculator can handle these just fine as well. I'm using my other calculator here just to kind of speed up a little bit. But this comes out to be about this. Rounding to 3 decimal places, just like we usually ask you guys to do. I'm not even going to bother with this one. How do I know my calculator is not going to like that? It's undefined because of this division by 0. Also, you can think about, if you really dig deep here, the domain of inverse cosecant is the same as the range as regular cosecant, which was this. And it skips 0. It has numbers up to -1 and numbers past +1. 0 is not in the domain of this, so that's why that does not work. So, not possible. Again, it's fine to put in your calculator, but you need to understand when it says you got an error, you have to know that your calculator is not broken. It's just that that can't be done. All right, and then last one should come out to be about that. So, not that those are difficult, but if you are not careful and you accidentally do this and do reciprocal angle, that's a completely different thing. These are reciprocal trig functions, reciprocal ratios. The ratio is the input when you're talking about inverse functions. Okay, are we still okay with this? Okay, and then moving on to the last part, this inverse cotangent is the pickiest of them, so we're building up to this. Inverse sine, inverse cosine, inverse tangent have been programmed in your calculator, so those just work. Inverse cosecant and inverse secant can work as long as you're careful about doing the reciprocal ratio. So for these, what I would expect you to do is to say, well, my calculator doesn't have an inverse cotangent button, but I can do like what we did in the last section and do inverse tangent of the reciprocal, inverse tangent of the reciprocal, and you want to pay attention very closely here because this is going to be easy to miss. But I can type all of those in my calculator. In fact, I'll just go ahead and do it right now. You might want to type in 1 or 2 of these in your calculator just to make sure you're getting the same numbers, but you don't have to type them all in. I'm going to have you practice this on those worksheets in a few minutes. Okay, and then this is where this one takes a lot more thought. Now, I could just tell you how to get the answer, and honestly, you can probably memorize it long enough to do it on the quiz. But we're going to aim for understanding what's going on here. Some of these answers are right, and some of these answers are wrong. This is why inverse cotangent's the hardest case. Does anybody have a guess which of these you think are incorrect? What do you think? This one? Nope, that one is perfectly fine. What do you think?
Is it the third one?
The third one is one of them that's messed up. What do you think?
The fifth one.
Okay, and what do the third and the fifth one have in common? Okay, so we got to talk about why that's a problem. These three were fine, and these two need one more step. So, well, I guess before I just tell you, does anyone have a guess on why these three worked and these two didn't, other than these are positive and those were negative?
Was the rim with the line? Or the rim?
Close, maybe. You might be on the right track. What is the range of inverse tangent?
0 to pi.
Inverse tangent's not 0 to pi. Okay, so when we're typing this in our calculator, again, our calculator understands how to do inverse tangent. So when I type this in, he thinks I want an answer in either quadrant 1 or quadrant 4. Your calculator is not smart enough to understand that we just had to rephrase that to ask the question we really wanted to ask. And what quadrants does inverse cotangent exist in? 1 and what? 1 and 2. That's why if it's inverse cotangent of something positive, it's not an issue because both of these exist in quadrant 1. That's why these three are fine. But if it's inverse cotangent of something negative, your calculator is giving you an answer down here in quadrant 4 because it thinks you want an answer in quadrant 4 because you're asking it an inverse tangent question. What you really want is an inverse cotangent answer, which has to be 1 or 2. If it's negative, it needs to be in 2. So I know somewhere down here, negative 0.1 radians is really close to 0. Where else on the circle is there going to be a place that has the same tangent value and therefore the same cotangent value?
Isn't it directly across from it?
It is directly across from it. And how do we go halfway around the circle to get directly across? Add what? Very good. Add pi. So, the summary that you may want to write in words is that only when you do inverse cotangent of something negative, you have to add pi to your answer. We will not ask you to explain why, but again, I think for your understanding and peace of mind, it's better that you understand why. When we type it in the calculator this way, our calculator is trying to give us an answer in quadrant 1 or 4 because that's where inverse tangent exists. But if we intend for it to be an inverse cotangent, it's supposed to be 1 or 2. So to go from quadrant 4 to quadrant 2 with the same values, you have to add pi to that answer. So this one was actually 1.902-ish, and this one is about 0.552. You only add pi if it's inverse cotangent of something negative. If it's inverse cotangent of something positive, it gives you a answer in quadrant 1. And quadrant 1 exists for both inverse tangent and inverse cotangent. So that's why that's not an issue. Okay, so the 30-second recap. Inverse sine, inverse cosine, inverse tangent just work. Those have been pre-programmed. Inverse secant, inverse cosecant can work as long as you do the reciprocal ratio. Inverse cotangent can work as long as you do the reciprocal ratio and you're careful about whether it's positive or negative. It's inverse cotangent of something positive, it gives you an answer in quadrant 1, which is what you want. But if it's inverse cotangent of something negative, the way we type it in the calculator is going to give you an angle in quadrant 4, but you want the angle in quadrant 2. So you have to remember to add pi to what your calculator says before you come up with the answer. Now, I know pretty much everybody who buys their calculator buys this type, and if you don't have your own calculator but you buy one someday, I probably would still recommend that you get this kind just because you're familiar with it. But just so you guys know, there's other calculators out there. TI makes one called an Inspire, and it has like a trig button that has those other things programmed in. So if you had that type of calculator, you wouldn't have to learn that second and third section on that page because those have been pre-programmed in. But for whatever reason, they just choose not to add them to these type of calculators. Okay, to make sure that hit home, let's backtrack. So on Monday, we did this 4.7 worksheet 1. I talked about how I quickly know the domain and emphasize the range, and we practiced some of these questions, but I did not go over question 4, nor did I ask you to try question 4 because I didn't tell you how to do these in the calculator yet. So I would like you to try these 4 questions in your calculator on the bottom of worksheet 1. See what answers you come up with, and then I will share my answers to make sure you're doing the same thing. And then we'll go ahead and just do the same question 4 on worksheet 2 to make sure that is all cleared up. So I'll give you just a second here, and I don't know, I guess you don't have to do this for homework points, but I do really recommend you guys write what you're putting down in the calculator for each of these to come up with the number. If you just put in the calculator, get a number, and write the number down, looking back at this to study for your quiz is not going to be real helpful. So if you write down what you put in the calculator to come up with that number, then I think that goes a longer way. So.
Stuff can come now, so.
Okay. Just make sure you either get a pass or have them mark it. I didn't hear what the plan was, so. Okay, I'm going to start them now as well, so you guys should be able to finish before me since I'm getting a late start. Bless you. Okay, there are my 4 answers from worksheet 1. Inverse tangent just works. Inverse sine just works, but that number isn't in the domain of inverse sine, so that's why my calculator spits back error there. Part D will work as long as you do the reciprocal ratio, which is the inside part. And part C, that's the tricky one, but I can almost promise you we'll put one of those on the quiz and at least one of those on the test. Closest you can do is inverse tangent, but you have to add pi before you get your final answer. Yeah. Yes, Tyler.
Can I just leave it as 0.228 plus pi?
Depends on what the question asked. If the question asked you to round the 3 decimal places, you really should go ahead and add them. We'd have to give you a calculator there. But if we made it no calculator, like how sometimes we do, then this very well might be like the answer choice. Because you need to, like, this would not be a good multiple choice answer because you may not know, like, which one added pi. But this would be how we'd write it as multiple choice. So. Okay, any of those you want me to talk about in more detail? So, not a lot of work, but this one is the trickier one. Understanding why you need to add pi there. Okay, just to knock this part out as well, worksheet 2, I'd asked you to do some of this for homework. And in just a second, I will start taking the questions that you have from that so I can help out. But go ahead and skip down to question 4 and do the calculator questions since those are fresh in our head. I'll give you a minute head start and then I'll do them as well. Okay, there should be your 4 answers. A, B, and D, all of those were just ready to go in the calculator, so I didn't even write what was there. Inverse tangent of negative 12 for A, inverse sine of negative 0.2345 for B, inverse cosine of negative 2 for D.
You done your insurance?
I haven't. I'll go by after class.
All right.
Thank you. D should have given you an error message because negative 2 is outside the domain of cosine. And the big one that I promise you we will ask, not that it's worth a million points or anything, but if it's inverse cotangent of something negative, just the way you type it in your calculator, you have to add pi to come up with that answer. If it's inverse cotangent of something positive, you don't add pi. If it's inverse tangent, inverse cosine, inverse sine, inverse secant, inverse cosecant, you don't add pi. You only add pi if it's inverse cotangent of something negative. Unless you have a different, fancier calculator that has all of the trig functions built in. Okay, now to be honest, or before we move on, is there any of these you want a little more detail in? Okay, so we will, when we get to the quiz next week, there will be a few calculator questions, and there might be a question or two on graphing inverse sine, inverse cosine, and inverse tangent. But the bulk of your quiz is going to be knowing the domain and range of the inverse functions, and you can just straight up memorize those. That's like 6 to 12 points on your quiz and test. And the bulk of the questions are going to be like question 2, where it's inverse trig function of something from the unit circle or something not from the unit circle that we have to sketch a triangle on. So we've been talking about the other stuff today so that you can see that, but the bulk of the work is like questions 1 and 2 on worksheets 1 and 2. So next up, I would like to try to help you out with your homework. So last class on worksheet 1, I went over questions 1 and 2 with you to kind of show you the approach and show you how to come out with the right answers. And then I asked you to try questions 1 and 2 on worksheet 2. So I'm going to go over question 1 just real quick, whether you guys ask it or not, just because it doesn't take very long if you have them memorized like I do, and I think it's good for you to hear it again. The domain of inverse trig functions are the same as the range of regular trig functions. So the range of sine and cosine are now the domain of inverse sine and inverse cosine. The range of tangent and cotangent is now the domain of inverse tangent and inverse cotangent. The range of inverse cosecant and inverse secant is now the domain of inverse cosecant and inverse secant. So indirectly, you already have those memorized from the last unit. You just have to know why the ranges became the domains.
You leaving? Make sure you have them call it in.
Excuse it. Okay, the ranges, these come from the restricted domains. So in theory, you could derive these, but that's what we did in your notes last time, and I suspect you don't want to derive them. So this is why I say you should memorize them. This is what you quizzed on when you first came in. I remember that 3 of these use quadrants 1 and 4, and 3 of them use quadrants 1 and 2. Oops, that is not right. And for me, I remember which one is inverse sine, inverse cosine. The reciprocal of inverse sine has a hole in the middle. It'll be right there. The reciprocal of inverse cosine has a hole in the middle. Inverse tangent has holes at the endpoints. Inverse cotangent has holes at the endpoints. So that is my shortcut to know what these are. The range of inverse sine is negative pi over 2 to positive pi over 2. Include the endpoints. Tangent is negative pi over 2 to positive pi over 2. Don't include the endpoints. And inverse cosecant, we need all of these values. Skip 0, and then all of these values. And then I kind of apply the same thing with inverse cotangent, or cosine. Inverse cosine, I just memorized that one. Inverse cotangent's the same thing, except that he does not include the endpoints, so parentheses instead. And inverse secant, we need all of these, which would be 0 to pi over 2, but can't include pi over 2, and then pi over 2 to pi. So I'm not saying that it's even the most efficient way to memorize them, but for me that has seemed to be the best for most students. So you have to know these. Your answers for all questions in part 2 have to land in these ranges. So if you don't have those straightened out, you're going to be giving answers that have 0 chance of being correct in the end. Your final answers have to land between the range of its trig value. Okay, so all that being said, I need y'all to tell me which questions from part 2 you tried, checked your answers to, and were struggling to get the correct answer so that I can help by going over those again. So which questions from part 2 on worksheet 2, the part that was your homework if you didn't finish it in class? None? I thought you guys would have several, but yeah, check. H. Okay, so within these questions, again, they really split into 2 paths. Some of them you need the unit circle, the others you need to sketch a triangle for. This, x over 1, that is certainly not a ratio that sounds familiar to me that when I memorized a unit circle. So I know, without really spending any time on this question, I'm going to have to draw a triangle. If it's got this outer layer, the outer layer just kind of comes along for the ride. We'll use that at the end. Now, I don't know if I said this or if I just thought it, but to me this is probably the second hardest thing that we do first semester. The first hardest is probably verifying the trig identities, doing the trig proofs. This is probably the second hardest. But that being said, these questions have a lot of repetition. You're going to make a triangle, you're going to do SOHCAHTOA, you're going to do Pythagorean theorem, you're going to finish with SOHCAHTOA. So if y'all ask any of these others, they're all going to finish with SOHCAHTOA, Pythagorean theorem, SOHCAHTOA. Now, if you just randomly make a triangle, sometimes you're going to get lucky and sometimes you're not going to get lucky. You need to put some thought into what quadrant that triangle is going to land. So inverse cosine, I know the range of inverse cosine is 0 to pi. That's important here because I know that inverse cosine only cares about quadrants 1 if it's positive and 2 if it's negative. This is a positive x, so I should draw my reference triangle in quadrant 1. And then here is SOHCAHTOA 1. Cosine is adjacent over hypotenuse. Pythagorean theorem. Y'all need to be careful with Pythagorean theorem here. You're welcome to come see your second test here pretty soon because most people have made them up, but a lot of times, not a lot, but far too often you guys are being careless with Pythagorean theorem. You're not putting the hypotenuse in for C, where you were doing better about that earlier this year. So, SOHCAHTOA, Pythagorean theorem, and then SOHCAHTOA. I want to know the sine of this angle, so opposite over hypotenuse. That's where that answer should come from. Again, not an easy question, but all of these should be pretty familiar. Think about what quadrant to draw the triangle in. SOHCAHTOA labels 2 sides, Pythagorean theorem to find the 3rd side, and then SOHCAHTOA to get your final answer. So after you do a handful of them, they should get better. Okay, what else from worksheet 2 can I help with? Yes? Okay, sure. So again, every one of these, this is either a unit circle question or a sketch a triangle question. And when I glance at this, I don't recognize this. But the reason why I don't recognize this one is because I don't memorize secant values. So I can change this to an inverse cosine question as long as I do the reciprocal ratio. And if you get to here, you might think that that's not real helpful because this doesn't look familiar. But the reason this doesn't look familiar is because it's not rationalized. In calculus, we almost never rationalize. It's not that important in calculus. But in trigonometry, you need to recognize this. So if I was to multiply the top by the square root of 3 and the bottom by the square root of 3, that's really the same thing as this, which is now very familiar. This is unit circle. So go around the unit circle. Everywhere where cosine is negative square root of 3 over 2, put a dot. Draw in the range of inverse cosine, 0 to pi. This helps you see where your answer comes from and doesn't come from. Name that angle, and then make sure that that angle is between 0 and pi, because it's inverse cosine. 5 pi over 6 would be your answer. Now, this doesn't apply to us, and I'm a little hesitant to even say because I don't know how often they put this on the ACT, but I do know that in the past they put this type of question on the ACT. They don't put real complicated ones, probably not anything like this on the ACT, but I have seen some like these. And ours would certainly be no calculator on this part. Well, honestly, a calculator probably wouldn't help you anyway. But just so you guys know that if you were trying to go from here to here, like maybe on the ACT, you can ask your calculator, what is inverse cosine of negative square root of 3 over 2? And it's going to say some decimal answer there. And I don't know, if you thought the answer was, I don't know, pi over 3, you could type it in and you can see that these are not equivalent. So pi over 3 is not the correct answer. We got 5 pi over 6. 5 pi over 6 is the same thing. So when you have a calculator, just because that doesn't apply for this class very much, you can do that as a quick little check. That might be quicker than working it out by hand. Okay, is that enough for K? Okay, others from worksheet 2. Okay, that's fine if you don't have them, but need to make sure I give you a chance. Okay, to finish up class today, on a blank piece of paper, if you go ahead and copy down that book assignment and get a few of the questions completed while you're here. Y'all have about 32 minutes, so you should be able to get a couple questions done at least. And the only homework I'm asking out of you is to do a couple more of these. And the reason why I want you to do a couple more is just to make your brain think about it again sometime between now and next Monday. But just to be clear, you do not have to have the book assignment completely finished on Monday. I will give you more time. But there's no reason not to spend your 30 minutes on it. And after I give you all a few minutes to get started, I'll come around and try to help individually. Yeah, and you will need a textbook. I'm sorry, I didn't put the sign up. I had forgot. So maybe if you have one person from your table, grab a book for everybody.
What else you got? What else you got?
I'm leaving for a duck hunt.
I'll go with you.
Maybe not. I would have invited you, but I don't think you want to get up at 1 o'clock and say I don't think about that.
Hey, before you finish upstairs? Alright, have fun. Why are you going, Jeff? Huh? Why are you going?
Because I want to go.
It's boring. Oh, what have you done? What have you done? We're probably on the ocean this year.
Why? I'm going to go Goshen this year. You're not going to. We can't hunt the same spot every weekend, Jacob.
We'll probably buy it too. And then,
We're going to hunt the same shit.
junkyard.
Well, I'm not going to want to drive to Fort Smith.
So 6. So we went 6 houses. Spinners. Like 3 divers. What did you say? Oh, I did say. Oh, we could get them out. Oh, for this straight over to Colton. Because he thought he was going to get it.
Okay, I know you guys just got started, but as I come around, if you've found something that you're stuck on, just call me over so I can help get you unstuck. That would be no count. And part of, when it says exact, that's what that's referring to. If you put it in your calculator, it's going to give you the best. You would have to round it. Now that we have reviewed inverse functions, do y'all understand the daily mean?
Yes.
Instead of a cat eating a fish, it's a fish eating a cat. I like that. I don't know why I like that one, but I do. You know where to find the class recording, just find out what you missed from that day. One on the right. That's in the inverse. So anything about that?
What?
You're saying cover the sidewalk.
Sign sometime?
That's all it is. The joke is not helpful. That's all I should get now.
I might think it's funny, but y'all would be.
No.
I'll give you more time later, but it's been entertaining that you already had 30, 40 minutes.
No. Nope. Oh, yeah. But, you know, and then this could also be on the opposite side. How do you know? This, I didn't get messed up this week. I got freaking some B team. I got demoted to the B team.
We don't have to get
The ladder. Turn this in. No, all these young.
You said
last time I did
What? What's the point?
Yeah? Yes. You know how you're gonna shoot.
Bird shot.
No. I don't think that would help at all.
Yeah. I mean, so what? Like, it's bird fire. You know, it's very bright. Yeah, it would matter a lot of shot. If you're shooting bigger stuff, if you're shooting a flying bird, you knowing where the pellets are supposed to go is not gonna help. What? Shot them in. There.
On 9 is the inverse of why would it not be negative tires?
87 on the upper.
Well, negative pirates, but you're talking about quadrant 4.
Yes.
And 10 is negative in quadrant.
No, like, 5 out of 10.
Oh, so.
Hey, I gotta be very careful. Straight to B. But I got 3 APs though, so it cancels out. No, it's 82. So this one's 89. It's almost a real A. Yes, sir.
Oh, and the agents, the ones who get them. Literally as close to the x-axis.
No.
Okay, that's what I thought.
Because you're good at math. I got 10 apples. It's because I make straight B. I'm stupid. No. Yeah.
Yeah. 9 pi over 6. Girl. No, I like, I'm just like, mine's
I don't know what about what the animal, but just thinking, but if you go once,
so like, yeah, so
hot.
I would do
Oh, the red.
Would we want me to do that?
Okay, L red.
so what is that? One. No, one. The first one was 1 over 6. It's pi over 6. You had it, just.
Why?
She said she would.
You know, we got banned. I don't know. He told me. He Snapchat got locked and I said for why. He said step 3 activity. I said it. I think that's one of the people pretty stressful. It worked. I said good.
One.
I swear. I swear. Well, they were hunkers. That's what it is. Yeah. Might as well. Yeah.
Alright, question number 1.
See?
What's the first one? 5?
5, yes, sir.
Sounds good. Alright, question 2, number 7. Is that right? Yeah. Square sine is 1/2 within the range of inverse sine.
I thought it was the other way around.
Number 7.
Me and you thought.
Pi over 3.
Cosine is 1/2 at pi over 3.
By the
Yes.
y-axis is not divided by 3.
What about number 9?
Pi over 6.
Yep. On a roll.
Oh, we're on a roll. We're rolling. What do we got for 11? Oh, we're rolling. I'm rolling, dude. Full steam ahead.
You just say that. Okay. I need to think about this.
white and
Okay.
do you remember what inverse function looks like graphically? This should be a line of symmetry. So this line should be
How would this say? You need no solution?
we'd have to
That'd be
have
logical.
our part of the cosine graph. This,
For 11
because
would
this,
Nico did no solution.
flipped it over this line,
That's logical.
this lands here.
I like it.
That's a visual that's always true
We're
in
rolling.
inverse function. You can flip them over. Just do a quick sketch of this on your paper so I know you did it. Well, you did it accurately, but I need to see that you did it.
Go with my grandma.
Sketching a triangle is not gonna help here, because this is an inverse
grandma used to
on the
always tell me
outside.
to text big
So
dog
your
the
hand
way
should
it's
tell you
on.
an angle. Drawing a triangle is not gonna help. You need to think of
What a guy.
where is tangent square root of 3/3?
Takes a big dog to watch it.
15 is too far.
Do you memorize tangent values?
Oh, yeah.
15 too far.
Okay, well,
Working together.
what
Rolling.
quadrant is tangent positive? Okay, so we wouldn't bother with 2 or 4.
Roll.
In the middle, do you know what this tangent value is?
You did 13.5 or 3.
But I'm asking for tangent, not
That's what I
sine.
said.
Okay, well, sine is square root of 2 over 2, and cosine is square root of 2 over 2. So sine divided by cosine would be 1, because they're the same.
Wait,
Directly across the
negative cosine. The negative third.
Sine divided by cosine, and you actually do upward, you're gonna get square root of 3.
That's not
what you
15
want for
is,
this
though.
question. So it's the one near the x-axis is divided by. But you can skip, you can skip the guess and check if you memorize.
Negative 1. Oh. Oh. 226. We're rolling.
So is that sketch, but you don't have to because it's.
So you have to learn in a row and outright.
Where's it code from?
Alright, so 17. How do you figure this? 9, negative 1. So arc sine square root of 3 over 2. So it's negative. We're rolling. Are y'all rolling? Oh shit, y'all are rolling. Yeah, rolling. Crawford said a wall.
You're using the values that you get.
Shut up, Jeff. Here goes Jeff. I'm trying to
No, you
find
write it in the values that you get. So what trig equation uses those two values?
All students here have. That's all it's okay.
Wait, where's 19? I mean, he'll do that. I don't think.
You use the inverse of tangent x.
Yeah, do that stupid eye roll.
No.
Is 13 entirely good?
Yeah.
So is that?
Yeah, but you got it.
Oh,
Reverse back.
he does everything. He crosses his legs over from day. Gives it one of these. Oh, why?
You going to Breezy?
So you have to do it the other way, which is gonna be negative.
They don't come in. Cool, can I come with? Can I come with?
You gotta be strict.
This thing.
You gotta be strict. You just told me no.
But you said
Take it.
And I did indeed invite you like twice.
When?
I didn't indeed not but
You invited me on Easter Sunday. Day of. Like, I got on the church and you called me and you were like, hey, you trying to go hunt turkeys and bruising?
because he was still but he didn't let go.
I wanted to go, but freaking, he called me a day of on Easter. And it should be like bail on my whole family. But we don't do 29. Oh, but look, hang on, I'll take up the break. Look at progress. 29, 21. Hey, just come back.
It's gonna be
I have a question on 45.
Okay.
It says, finding exact value of the expression possible. Well, I'd probably change this to a fraction. Okay, so it's 3/10. That's not a ratio on the circle, so you're gonna have to sketch a triangle for that. Label opposite as 3, hypotenuse is 10, so there's subtoe number 1, diagram there for the other side, and then subtoe again, if you want to sign it. Okay.
Ooh, yes.
Thank you.
23.
Huh? What did you just say?
When we were playing cards and you were kicking up there.
I'd kick underneath.
You just said do it to Crawford. No.
Wait,
No, I'm just right underneath.
how?
Right underneath.
But I'm still in the zone.
Oh, good.
He goes, I can feel it in my knee. I said that this morning.
Going with Jet what? No. He didn't invite me. Well, once again, my somebody invited me to the future.
You just signed
I invite y'all to do stuff. I wreck my truck. Y'all say never do it ever again.
this triangle.
Why? Are you serious?
It's just a sign. When you create the triangle.
What does it do?
It's 3. No, it's a 1. It's a 0.3 over 1.
I don't know what to tell you.
Because if the arc sine is 1, so 0.3 over 1 is how you get to it.
Oh, you're about to get to
Sign a negative 1.
Yeah, that's,
Wait, you get no
it's asking the
solution for
same
27?
problem, and they do the same exact thing. We just know.
27.
Wait, what's that? Just find the time, click and all, so you have a point 3 as your R, and then your hypotenuse is 1. If you don't have a fraction, you put your hypotenuse. And then if that, it doesn't matter, because now that you have that triangle, what's the sine of that triangle?
So you have a sign?
And the answer is so, oh, that's just like, it's actually quite not the. But then the other one.
I got a long ways done with you.
So it gives you that angle, and that doesn't fit in arc sine. That angle is in arc sine angle.
For these 39 through 44, what does it mean by like use an inverse trigonometric function to write that as an x? Like, do I just pick a function and?
No, they want you.
That's so cool. What? I've never seen that.
Yeah. I just use it to like jump around quickly and stuff. So I do less of this. So you've got this. What's the other one?
4 on the bottom.
Okay, so you could do. What number is this?
No, 39.
Oh, the x is over here. So you could do a regular tangent equation if you did opposite of adjacent.
You're just finding x?
No. Are you okay with why this is true?
Yes.
Okay. They want you to come up with an equation for theta, though, in terms of x. So if tangent theta equals this, then theta would equal the inverse tangent of that. That's what they want you to do.
Okay.
That'd be a way to go